All right, let's go through the solutions for practice exam number 3. Number 1, they gave us that our function is 1 over the quantity x squared plus 9. And then in part A, we're trying to evaluate the improper integral from 3 to infinity of f of x dx. Of course, you can just substitute in the 1 over x squared plus 9 here to start to rewrite this. A couple things to keep in mind. This is improper, so every time we have an improper integral, we need to rewrite this as a limit. Use some variable here. I'm going to use the letter A. The choice of letter is not important as long as it's not a letter that's already in the problem. And they actually give a point for rewriting a limit expression. So some of you didn't do that, and you lost that point, even if you came up with the right answer. So the technique, the process, and the concepts behind things and how they work are important. Now, a lot of us had trouble with the antiderivative of 1 over x squared plus 9. Some of you thought you could factor it. You thought it was x squared minus 9, so you factored it x plus 3, that quantity, times x minus 3, which doesn't work. And you don't want to try to factor this over the complex numbers. Here, you either want to do a trig substitution, which would work. It's a little more work than is necessary. We did this example in class a few times over last year and this year, but I don't think a lot of us remembered. But I tried to show it to you when we were going over trig substitution. I tried to show an example like this so you can see that there's another way of doing this that doesn't require trig substitution and works out to a familiar result. And I saw some of you remembered that because I saw some of you do the technique. You can factor out a 1/9 here because this looks awfully similar to the function that's the derivative of arctangents. Arctangent's derivative is 1 over x squared, and this is almost that, except instead of 1 plus x squared, we have 9 plus x squared. So we need to get a 1 there. So if we do that, then, and I'm going to switch the order in the denominator, and I can write this as 1 over 1 plus x squared over 9, like this, and starting to look a little bit more like, well, maybe, if it's not looking like more like arctangent, then so be it. But it is, with enough experience, I guess. I could factor or rewrite x squared plus 9 as x plus 3 quantity squared. And then you could do a substitution there, letting u equal x over 3. So du is going to be equal to 1/3 dx. And we don't have that 1/3, we have a 1/9. So there's a couple different ways of handling that. You can do 1/3 multiplied on both sides, and then you can replace the 1/9 dx with a 1/3 du, or you could have just multiplied both sides by 3. Either way is acceptable. It doesn't really matter. But nonetheless, when you rewrite this in terms of u, either way, you're going to get 1/3 1 over 1 plus u squared du, which of course is going to be 1/3 arctangent of x over 3. Arctangent of u, but I'm just going to get to that step and replace u immediately. And so that's our antiderivative that we're going to want to use in our limit and definite integral expression that we have up there. So this is going to become the limit as a approaches infinity, and we're going to have 1/3 arctangent of x over 3 from 3 to a, and again a is going to infinity. So we're just applying the fundamental theorem here. Limit as a goes to infinity, and we're going to get 1/3 arctan of a over 3 minus 1/3 arctangent of 3 over 3, which is just 1. And then from there, it helps to remember what the graph of the arctangent function looks like. And this is something that we've talked about before. A over 3, as a goes to infinity, is just going off to infinity. And the arctangent function, I always say every time we go over this that you're going to see this again, and not because I knew it was going to be on this particular exam, but it does pop up. For all of the inverse trig functions or arc trig functions, it comes up probably the most frequently. So arctangent looks like this. And we have y equals pi over 2 and y equals negative pi over 2 as our two horizontal asymptotes. And so this up here is going to become, well, the first part's going to be 1/3 times pi over 2. Because, again, we saw that 1/3 is a factor, and arctangent, as the inputs get larger, goes off to pi over 2. And then you have to remember that arctangent of 1 is pi over 4. You think of arctangent of 1 as the angle that you plug into the tangent function that produces 1, and so that's going to be pi over 4. You could stop right there, okay? If you get to that point, you're correct. If you want to go a step further, it's pi over 6 minus pi over 12. Well, this is really 2 pi over 12 because pi over 6 would be 2 pi over 12. So 2 pi over 12 minus pi over 12 is still just pi over 12. You don't have to do the simplification. You don't have to do the arithmetic. You could stop way back up here and be correct and get full credit and not waste the time to simplify or risk making a mistake. How do I get back to the screen so I can pause? So part B says to determine whether the series, which is the sum from n equals 3 to infinity of f of n converges or diverges, state the conditions of the test used for determining convergence or divergence. They really set up a simple problem here that most of you made overly complicated. And why I'm calling it simple is the work that we did in part A could be used to answer this question. Okay. Whoops, this should be an N. I don't know. Some of you put an X in there inside the summation, even though it should be an N. I hope they don't penalize you for that, but they could, so be careful. The reason why I say you could use the work from part A was because we have our integral test, right? We just worked out that the improper integral from 3 to infinity of f of x converges. And so as long as we meet the conditions of the integral test, then we could use the result from part A. Notice they said just state the conditions. So we don't have to actually go through and prove anything. We could just state the conditions. So f of x is equal to 1 over x squared plus 9 is continuous, positive, and decreasing on the interval from 3 to infinity. So, by the integral test, the series from n equals 3 to infinity of 1 over n squared plus 9 converges. And then, you know what? I'll be honest with you, actually. I want to include one more thing. Since the integral from 3 to infinity of 1 over x squared plus 9 with respect to x converges. I'm trying to remember the solution guide at the moment here. I don't remember. I think you should say that. I'm not 100% certain. I'd rather you say that than not, just to be sure that you get the point. All the points that you deserve for that one. Now, some of you didn't use the integral test, and that's fine. There are other ways of proving, and I'll go through some of those really quickly. So 1 over n squared plus 9. Now, that's not one of our it's not exactly one of our series, okay? Some of you did the basic comparison test, and you did a good job with it, most of you who did that. So you started with something like n squared is equal to n squared. So you get the one side bigger by adding 9. And then you took reciprocals like we did in class. And then the series 1 over n squared is a convergent p series with p equal to 2 greater than 1. So by the basic comparison test, the series 1 over n squared plus 9 converges. Okay. Now you got to be careful if you making your statement here. In your statement, if you leave off the series, the summation rather, with the expression, then it's not the same thing. And and they're going to deduct points from you there. You can do a similar test using the limit comparison test. So you could have done this, and again, some of you did. And then I'm going to be a little more sloppy with this one right now because I've already shown you two other ways for this to work. So at that point, then just say, since the series 1 over n squared is a convergent p series like we did above, by the limit comparison test, they both series converge. So there's 3 different ways you could have justified the answer to that question. And if you didn't get it, that was not a very challenging series, and so you should be able to get it. Go back and study a little bit more carefully, pay attention a little bit. I know you can get it with a little bit more attention to detail. So with part C, it says determine whether this series, and you should be thankful they did the algebra for you, because they gave you the original. They could have stopped by giving it to you as the sum from 1 to infinity, -1 to the n over e to the n times f to the n, but they did the algebra for you. They didn't want the algebra to be a problem for anybody, so that if you screwed up the algebra accidentally, then you can't answer the question. They don't know if you actually know something about series, or that series in particular. They don't know if it converges absolutely, conditionally, or if it diverges. Remember, absolute convergence, if I can look at the series formed by its absolute values, if that converges, then the series is absolutely convergent and thus convergent. If the absolute value of the series formed by the absolute value of the terms diverges, then I have to go back and take a look at the original series and see if it converges, and if it does, it's conditionally convergent, and if not, it's just divergent. So you can go back and rewind that if that was too fast, if I said that too quickly. But nonetheless, if you're looking for absolute convergence on the AP exam, it's more than likely you're going to be using the ratio test, and that's what we're going to be using here. So let's go ahead and get into this. And so the ratio test, they give you a point if the ratio test is going to be used for setting up the ratio properly. So we don't need the -1 to the n, because we're going to have those absolute value symbols around everything. And so that's going to go away. Oops, right. We get this. And they will not penalize you for skipping down to this step here. It's the same thing. Which is mathematically equivalent to setting the proper ratio. You're good to go. And then from here, when I cancel this out, I'm left with a factor of e down here. And then this limit, these terms here have the same highest power and then the same coefficient even, except for this factor of e in the denominator. So this whole thing, that part in the elongated bubble there, is going to go to 1, and then e still in the denominator. So this whole thing goes to 1 over e. So they give you a point for setting up the ratio correctly for the ratio test with this limit. They give you 1 point for evaluating it to the correct limit. They give you another point for the conclusion based on the ratio test, and 1 more point for referring back to the original series, which to me I think is a bit redundant, but that's how the score was written. Now, so the conclusion has to be based on the fact that 1 over e is less than 1. Okay. Now, since this limit is 1 over e, which is less than 1, by the ratio test, the series from n equals 1 to infinity, -1 to the n, e to the n times f of n is absolutely convergent. That's how you had to do that one. All right, so we have a differential equation problem here. We have some initial conditions, diffie-q, and whatnot. Write an equation for the line tangent to the graph y equals f of x at x equals 0, and use it to approximate f of 0.5. Straightforward, easy question right out of the box. So what we need is, of course, the equation of a tangent line is something like this. Well, we know a is going to be 0. We know f of a is already 2. We just need the slope. That's what the differential equation is for. So for the differential equation, we just need to plug in the 0.02 into x and y, but there's no x, so just y, and then we'll have our slope. So 10 minus 2 times 2, which is going to be 6. Some of you very sillily, whatever, very carelessly plugged in 0 for y instead of 2. And then we got this simple problem wrong at that point. So, but you're going to get y equals 6x plus 2 as the equation of the tangent line. And then we need f of 0.5, or an approximation for f of 0.5. So we're going to plug in 0.5 for x, and then we'll add 2, which works out to be just 5. Pretty straightforward. I believe that's 2 points, one for the tangent line, one for the approximation. Be careful here. Don't put an exactly equal to sign here if you're going to write it like this. Sometimes they have in the notes to take a point off if you put exactly equal to. So just be careful with that, please. For part B, we want to find the second derivative of y with respect to x at 0, 2, and then determine if the graph of y equal to f of x is concave up or concave down, and give some reason. Should be another straightforward question, but some of you made some silly mistakes on this one. We're just going to differentiate this equation with respect to x, which gives us this notation over here. Derivative 10, of course, is just 0. This is where a lot of you, not a lot, some of you made a mistake. Some of you got negative 2y times y prime, which is not correct because the derivative of y with respect to x is just y prime, okay? So if you did that, if you made that mistake, it's a silly little error that you don't need to make in the future. So please stop it, okay? Now, this becomes negative 2 times the quantity 10 minus 2y, because we know what y prime is. Y prime is all this stuff up here. That's y prime. So I can just plug that in down here and get this, okay? And then I need to figure out this evaluated at that point, 0, 2. And so I'm going to plug in not a 0, a 2 for y, and we get negative 12. And since negative 12 is less than 0, so the second derivative of y with respect to x at 0, 2 is less than 0. So y equals f of x is concave downward at 0, 2. Pretty straightforward. All right, for letter C, we want to find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 is equal to 2. So we're solving the diffie-q. And so let's get into that. Of course, our method for doing that is separation of variables. So some of you did a factoring over here. You factored out the 2 and put 5 minus y and then separated the variables that way. It does not matter which way you do it. I think fewer of you did it that way, so I'm not going to do it that way. I'm going to try to be consistent with what most of you did. But it's a fine move. No problems with it whatsoever. So if you did it that way, more power to you. So this is 1 over 10 minus 2y dy is going to be equal to dx. That's our separation step. And then our integral step. And then over here, you might want to do a little mental u substitution or actual physical u substitution, writing it out. Get this over here, and so we get a negative 1/2 du, and for the dy, and so this is negative 1/2 integral 1 over u du equal to the integral of dx. And so we get negative 1/2 natural log absolute value of u equals x plus a constant. So negative 1/2. Something feels wrong at the moment, but I don't think I've made a mistake. I think it's just the velocity, which is fine. no problems. We still have to work through those types of situations. All right, now we had an initial condition to deal with that I forgot. Oh, it's still f of 0 was 2. I thought maybe they had changed something on us, but no. So I'm going to use that to solve for c now so that I can then go ahead and solve for y after. So I get negative 1/2 natural log absolute value. 2 goes in for y, and so 2 times 2 is 4, 10 minus 4 is 6. So I don't even need the absolute value any longer because uh, the absolute value of 6 is still 6. And if I plug in 0 for x, I'm left with c over here. All right, so we get negative 1/2 natural log absolute value of the quantity 10 minus 2y is going to equal to x minus 1/2 natural log of 6. And then I would multiply through by a negative 2 to remove the coefficient negative 1/2 over here, which makes this the result. And then exponentiate both sides, which gives us this. Notice I still have the absolute value symbols on the left-hand side. Most of you dropped them right here. They, in their point scheme, they didn't give a point on how you handled demonstrating handling it well. So I think some of you got lucky on this part. But hey, we could all use a little bit of luck every now and again. Just as a reminder, this could be written as this, which could be written as e to the negative 2x times 6. Okay, so 10 minus 2y is going to be plus or minus 6 e to the 2x, e to the negative 2x, excuse me. And then start solving for y. So negative 10 plus or minus 6 e to the negative 2x, or you can put the minus 10 at the end, it does not matter. So solve for y, divide by negative 2, so I get a positive 5. A minus plus if you want to get technical, but it wouldn't really matter. They wouldn't penalize you. They penalize you for putting a 6 when there should be a 3. So now we got to choose the right one. Now remember, we have to hit the point f of 0, 2. And so if I put the 0 in for x and kept the plus sign, then I would get an 8. I don't want an 8, I want a 2. So I need the subtraction there. So the correct answer is going to be 5 minus 3 e to the negative 2x. I think they should use a negative initial condition, so you have to think about it a little more carefully and make the right choice. I think some of you didn't think about it and got lucky. So be careful. You should check to make sure that point is on the curve. Okay, whatever your final answer you box in, plug in that point and make sure you get a true statement. And if you don't, go back and fix it. All right. So for D, it says for the particular solution, y equals f of x found in part C, find the limit as x approaches infinity of f of x. So we're just taking the limit as x approaches infinity. This is literally a 1-point question. So I'm quite sure why it's there. They want you you should understand that this part over here goes to 0 and this works out to be just 5. They don't require any work whatsoever, but just to make sure we understand, because we have that e to the negative x. Normally the exponential goes this way, but as soon as you make the exponent negative, it flips it around the y-axis like this. And so the factor of 2 is a stretch factor. It doesn't affect how it behaves in the long run. So, this part here is going to 0 because of that part of the graph right there. And so the limit is just 5. Hopefully, these solutions were enlightening. A lot of us are close. We're making some silly mistakes. I can see the content there, and the concepts are starting to come through, but we just need to be a little bit cleaner in how we handle things, and we can get more points than we actually have gotten because of a little bit of sloppiness or a little bit of forgetfulness on certain things. So I know we can do better, so let's keep pushing ourselves. We're almost there, ladies and gentlemen. Hang in there. Keep driving. We'll get there. Go steady.